Welcome to part 2 of November 2017, paper 1, higher level. We are on question 21. By which factor will the rate of reaction increase when the concentrations of X and Y are both increased by a factor of 3? Okay, so we have X, which is 0th order. So it means that if we increase by a factor of 3, it won't make a difference. So what we'll be looking at is the fact that y is second order. So we know that's an exponential graph. So x 0th order, nothing. Y second order. So 3 to the power of 2 will give us 9. Yeah, so we simply take the factor and then to the power of 2 because it's second order. So that will be B. Which pair of statements explains the increase in rate of reaction when the temperature is increased or a catalyst is added? So the temperature is all about the average kinetic energy of particles. So if we're increasing the temperature, then we're also increasing that kinetic energy of the particles. So A or C. When we add a catalyst, that's all about the activation energy. The activation energy decreases if we add a catalyst, so that will be C. Which relationship is always correct for the equilibrium of this temperature? We are given the Kc. We know that Kc equals products over reactants to the molar ratios rather. So that means H2S squared over S2 and H2, and that is also squared. So when we do that, they're telling us we get a really big number. Big number. So what does that mean? That means that the products must have a big value. So the value of the products is really high, the value of the reactants is really low, so that we can get a very big number. So that leads us to D. What will happen if the pressure is increased in the following reaction mixture at equilibrium? Pressure. So pressure is all about the moles of gas. So if we increase the pressure, the equilibrium will shift towards the side with the least number of moles of gas. So it means it will shift to the right because there are no gas moles there. So that will be A or B. Now, because we are adding hydrogen ions, it means that we are making our reaction mixture more acidic. So that means the pH will decrease. A. 10 centimeters cubed of an aqueous solution of sodium hydroxide of pH 10 is mixed with basically 1,000 centimeters cubed of distilled water. What is the pH of the resulting solution? Okay, so we have NaOH. Now that is a base. That's a base. So you're diluting OH minuses, yeah? So you're adding through that water a lot of H pluses, lots and lots of H pluses. So that means that we are becoming more acidic. so the pH will decrease. So either A or B. Now it is a difference of 2 units here between these two numbers. Twofold increase. We have 10 to 100 to 1,000. And yeah, it's okay to round up to 1,000. 2 units, so that will be 8, from 10 to 8. Which of the following will form a buffer solution if combined in appropriate molar ratios? Right, so if we want a buffer, we want an acid and a base. An acid and a base. So A, hydrochloric acid, lovely. NaCl, no, that doesn't really offer us anything. We need some hydrogens. Option B, there we have 2 bases. So that's 2 bases, so no. C, we have 2 acids. So again, no. And D, yes, D, we have acid and a base. Next, which indicator is appropriate for the acid-base titration shown below? Okay, so we are looking for basically the middle point here. Sort of middle point. So that takes us to somewhere around there. Now A is nowhere close, B, no, C, no. So the closest is D. Now that is still a bit higher than the midpoint, which is fine because they have quite a large range. It's also good when you practice questions like these to think about the implications of the graph. So what sort of graph is shown here? We have a strong base and a weak acid graph. And what would be the color change? We would go from pink to colorless. So that was D. Next, which statement is incorrect for a 0.1 mole per decimeter cubed methanoic solution? Methanoic acid solution. Incorrect, incorrect. Okay. A, pH is 1. Yeah, looking at the concentration, that seems correct. But it isn't. That is the incorrect statement. Why? Because this solution is a weak acid. This acid is weak, so it cannot have a pH of 1. Okay, so yes, the answer will be A. If it's a weak acid, it means that it only partially ionizes. So that's why D is correct and therefore not the right answer. Now, B and C, let's have a look at those. Now, because it only partially ionizes, it means that the equilibrium will lean far, far that way. So we'll have a lot of this. And these we'll find are pretty equal in concentration. So yes, this refers to that. And if we have a lot of this here, it means that the concentration of hydrogen ions will be lower. So B is also correct. So yes, the answer is A. Next, which of the following is a redox reaction? You know that my tip is always to look for elements. I can already see that in A, we have magnesium and aluminium, so it will be A. I don't even need to check. We know that elements have an oxidation state of 0. So if they're then in a compound, they will have to have either a plus or a minus value, which means oxidation reduction has occurred. Next one, consider the following half equations. Which statement is correct for the reaction between these two in acidic conditions? Okay, so they're both plus. We know that one of them needs to be a minus. I don't remember which one do we need to turn. It doesn't matter, because what we know is that an E cell must be positive. Okay, when you add these two numbers after you've flipped one of them, we need to get a positive value. So the one that you're going to flip in order to stay with that positive value is going to be this top one. So it's going to be minus 0.54 instead. Because if we flip the second one, we'll get a negative E cell. Okay, so that's how you do that. Now, the more positive value is the oxidizing agent. If you think of your table 24, at the very top you have the more oxidizing agents, at the very bottom the more reducing agents. At the very top you have the most positive, at the very bottom the more negative. So that means our manganate, that will be the oxidizing agent. So manganate therefore cannot be reducing anything. So it can't be A. B, the iodide ion reduces why yes, yeah. If manganate is the oxidizing agent, the other one will be the reducing agent. So that's correct. The color changes from brown to purple. No, it actually changes from purple to brown. So switch that round. And D, manganate is not oxidized. It itself is the oxidizing agent, which means it is reduced. So we are left with, so our answer is B. What are the products when an aqueous solution of copper 2 sulfate is electrolyzed using inert graphite electrodes? Okay. So we have an aqueous solution. Aqueous, that means we have water. So alongside our copper 2 sulfate, CuSO4, the SO4 has a 2 minus charge. We know our copper is a 2. So we don't need any of the little numbers because the charge is balanced. If we break these up into our ions, we have from the copper sulfate, Cu2 plus and SO4 2 minus. From our water, we have the H plus and the OH minus. So we would get the positive ions at the cathode, negative ions at the anode. Yeah, opposite charges. Cathode is negative, positive ions. Anode is positive, negative ions. But now we have to pick between each of these. Will it be the copper 2 plus or will it be the hydrogen ion? Well, the rule here is pick the less reactive. Yeah. Which one's less reactive? The copper. So you pick the copper because the less reactive will be able to accept electrons more easily. So copper on this side. What about on the other side? Sulfate or hydroxyl? The rule here is halide beats hydroxyl, hydroxyl beats anything else. Okay. So that is a very loose rule that you can base your decisions on. Now, the other condition that the question might have added is a dilute or a concentrated. So that's a different scenario. But in this case, the hydroxyl will win. Really, salts are never oxidized. Sulfates, nitrates, they never really get oxidized. So you know that if you've got a hydroxyl competing with a salt, it's going to be the hydroxyl. So that will be C. What are the oxidation states of chromium in ammonium, chromate, and chromate? I think so, but it doesn't matter. You don't need to know the compounds. Let's work it out for the chromate. O3, that will be minus 2 times 3 minus 6. You've got two chromium atoms. You want to get to 0. It's a neutral compound, so that will be plus 3. A or B. Now for the other one, let's take it to the side. NH4, 2. Cr2O7. Well, this will be plus 2 because the ammonium ion is plus 1. This will be minus 14. Minus 14 plus 2 minus 12. We want to get to 0 again. We've got 2 chromiums, so that'll be plus 6. So that is B. Propene reacts separately with these different types of conditions to give products X and Z respectively. What are the major products of the reactions? So you need to know 5 reactions for the alkenes. Here we have an alkene with water. That gives us an alcohol. So we know that X will be an alcohol. So it can't be C. Now Z will be, following the conditions, will be an alkane. Definitely not forming any triple bonds. Even if you don't know what this reaction is here, you know that you can't be forming any triple bonds. And you know it can't be C, so that leaves you with A anyway. But I would highly recommend you look over those 5 reactions and memorize them. What is the name of this compound using IUPAC rules? So longest carbon chain, 1, 2, 3, either here 4 or here 4, we don't know yet. So that would be bute. Methane, ethane, propane, butane, 4 carbons. So it won't be B. Okay. So we have 3 methyl and 2 methyl. So the 2 is which carbon is the methyl group on. Let's say we take the version that we've got now, which is like that. So the methyl group would be on the second carbon. Methyl group on the second carbon, so that'll be 2. And then 2-ol. Yeah, that matches up. Why is it not A? 3 methyl, 3-ol. Well, we know that the locant should be the lowest figure possible. So they are getting this 3 because instead of counting 1, 2, 3, 4, they are counting the other way. 1, 2, 3, 4. But we want the lowest locant. Lowest locant possible. Why is it not D? Well, we said the methyl and the hydroxyl are on the same carbon, so we can't have different numbers here. So that's why D is incorrect. And so we stick with C. What is the product of the reaction between pentantuone and sodium borohydride? Okay, so we need to know the oxidation of alcohols. We also need to know some reduction reactions. We know this is a ketone. It's going to be going back to an alcohol. Is it a primary alcohol or a secondary alcohol? This is where you need to know your organic. It will be a secondary alcohol. If you remember, primary alcohol goes either to a carboxylic acid, if it's reflux, or to an aldehyde, if it's distill. By the way, these two reactions do follow each other. So first you distill and you get an aldehyde, and then if you carry on, you get a carboxylic acid. That's something that I didn't know for a very long time. So really I should have written them the other way around, but now you know. And then a secondary alcohol just goes to a ketone. So that will be B. Make sure you know the agents that you need. So here was sodium borohydride, but it might be something else, which I think it is. So make sure you know those conditions. Which compound can be oxidized when heated with, well, oxidation of alcohols. It will be an alcohol, so it cannot be A. Cannot be D, that's a carboxylic acid. B or C. We know that we get oxidation with primary. We know that we get oxidation with primary OH, yes, secondary OH, yes, but tertiary, no. And this here is a tertiary alcohol. So it will be B. What is the number of optical isomers of isoleucine? The formula here, the magic formula, is 2 to the power of n, which is the number of chiral carbons. Chiral carbons, number of chiral carbons. So how many chiral centers do we have here? Remember, a chiral center is one that has 4 different groups, okay, surrounding that carbon. So this cannot be a chiral center, it has 3 hydrogens. This cannot be a chiral center, it has 2 hydrogens. This cannot be a chiral center because it only has 3 groups. We need 4 groups. So we are left with chiral center 1, chiral center 2, and that has 1 going up here, 2 going over there, 3 going all the way, and remember you do go all the way, and number 4 would be here, and it's a H. Yeah, and the same applies to the other chiral center. So that would mean 2 to the power of 2 equals 4. That is the number of optical isomers. Which functional group is responsible for the pKb of 4.1 in this compound? Okay, pKb, we're looking for a base. A base. So that means we're looking for a lone pair, something that has a lone pair that can be protonated, that can act as a base. We're looking for an electron donor. And we see that this nitrogen here has a lone pair. This one does as well. And so does this one. Okay, well, then let's just say it's this amino. Sure, the correct answer is actually an amino, but it's not that one. And that's because this is attached to a benzene ring. So the lone pair of electrons can delocalize into the ring, which will make it a weaker base. Even though it is basic, it's less basic than this one over here. That one has the lone pair that we need, that can be protonated. The equation for which I believe is this. Okay, so why is it not this one? That's the amido group, and generally that's not very basic. It does have that lone pair, but I've learned that instead of wanting to attract a proton, it will look to delocalize onto the C double bond O. So that's why it's not A. Now C and D, chloro and ether tend to be neutral. So when it comes to basic acidic, you can basically rule those out. Almost at the end. Which compound gives this H&MR spectrum? So we have 4 hydrogen environments. 4 hydrogen environments. Okay, so from the start, it can't be B, it can't be C. They only have 1, 2, 3. Hydrogen environments, 1, 2, 3. And this is very symmetrical. So in fact, there will only be 2 hydrogen environments. This will have 3 hydrogen environments. Now, is it A or is it D? Let's draw them out. Well, this is very symmetrical, so this environment is the same as this environment. Then this one, B, is the same as this one, so we only have 2 hydrogen environments. So that leaves us with D. Let's just draw that one out as well. So we have A, B, C, D, our 4 hydrogen environments. D. Last question. A student performs an acid-base titration using a pH meter but forgets to calibrate it. Which type of error? Okay, so that's to do with the method, which will be a systematic error. Just to illustrate the difference between precision and accuracy, if this is the true value, this would be accurate. If this is the true value again, and we get this, that would be precise. So this is low accuracy, high precision. This is high accuracy and probably high precision as well. So here we'd be getting a low accuracy. So that would be B. Well done for making it through. Stay tuned for the next one.